Hello and welcome back. When we were discussing steering linkage, we started at the pitman arm or the steering gear and worked our way out to the outer tie rod ends where they meet the steering arms on the steering knuckles. Today we're going to be going over the construction and configurations of different types of steering gears and the steering column and how they join together. For the steering column example, today we're going to be using a 2006 Chevy Cobalt steering column. We'll briefly go over some of the different components of this specific steering column assembly, and I'll cover other items that you might encounter on other steering columns. So starting up at the steering wheel, with the addition of electronics and components in the steering wheel's rotating assembly at the steering wheel, electrical connections need to be maintained through the entire rotation movement of the steering wheel itself without causing any damage or binding. This is accomplished through using what's commonly referred to as a clock spring. The clock spring is going to have an internal rotating piece and an external piece that's mounted or fastened to the steering column. The circuits that run through the clock spring may include airbag or SRS supplemental restraint systems, which will normally be classified as yellow connectors and shrouding on the wires. There could be horn circuits and different audio functions and cruise control functions from the steering column as well, which will be normal types of wires that you'll find on the wiring diagram. The clock spring, made of two separate pieces, will often have a cover on it, and it will conceal the internal pieces of the clock spring assembly. If those were to be removed, this ribbon or this clock spring printed circuit is going to be coiled up inside. And this is what allows the steering wheel to steer while still maintaining a safe and reliable connection of the wires that connect the different electrical components of the rotating part of the steering wheel. Here's another example of a clock spring, this one assembled. And you can see with the yellow wiring indicating that this is for a vehicle with supplemental restraints or airbags. Here's another example. There are no yellow wires on this one, so this would likely be from a vehicle that either has a separate circuit for the airbag, or it is not equipped with an airbag, or the airbag is located elsewhere. On the back side of this, you can see where a connector would connect to the clock spring to run the different electrical functions of the steering wheel assembly. Moving down from the steering wheel, there are controls that are stationary, like the turn signals, headlight controls, wiper controls. These are going to be part of the stationary part of the steering column that don't rotate with the steering wheel. Sometimes these are assembled as one unit across the steering column, and removal of the steering wheel and airbag would be necessary in order to replace or service those components. Other times they bolt independently directly to the side of the steering column. Service information is helpful when determining how to disassemble and reassemble and service these different components. It could mean the difference between a few minutes and a few hours to service some of these components. With the column flipped upside down, this is the underside. This is where the key fits into the lock cylinder. The lock cylinder is the mechanical component that fits the profile of the key and allows the cylinder to rotate and engage the different contacts on the ignition switch. The ignition switch assembly is usually going to be on the end. This is the part that actually has to turn on the internal piece to allow the vehicle to start and other electrical circuits in the vehicle to wake up and turn on. The immobilizer may be part of the ignition lock assembly, and it may be transmitting a signal to and from the key with a radio frequency to determine whether or not the key is present. And just for example purposes, this right here is the clock spring and the stationary part of the bracket, and we're right side up again. So again, here's where our connectors connect into our different components. Our clock spring right here on the rotating assembly. Ignition lock cylinder right here, usually with the immobilizer attached to it, coming down to the ignition switch or the electrical component of the ignition switch. There are mounting brackets. Oftentimes when working on ignition lock cylinders for security reasons, these are tamper-proof. So this used to have a screw head or a hex drive on it, and when it meets its torque specification, it snaps off. That way, somebody can't come in from underneath with normal set of tools and remove the hardware that's mounted in the ignition lock cylinder. It's a security or theft deterrent. Doesn't make anything theft proof, just theft deterrent. This is our lever for the tilt steering column. It engages and disengages and allows the steering column to pivot up and down within a slot. These may be of varying designs. There may be gear tooth designs. Some steering columns may be very complex with electric motors for telescoping and adjustability for driver preferences. But this is a common method for adjusting the steering column position, is with a locking lever to move the steering column up and down to fit the driver. The main mounting bracket will mount the steering column to the underside of the dash to the frame of the dash assembly. And then coming down from there, this one is equipped with electronic power steering. So the power steering function of this vehicle occurs through the electric motor mounted to the steering column. This is using electrical current and an electric motor to assist the driver in steering the vehicle directly at the steering column. So it's amplifying the force of the driver inputting into the steering column before we even get to the steering gear. So the steering gear would not have an electric power assist on it, and the steering gear would not have any hydraulic lines to it. The steering gear would look like it's a manual steering system. And as far as this design goes on the steering column with the electric power steering, the steering gear essentially is a manual steering gear. There's no assist occurring on the system other than at the column along the shaft. When servicing the different components of the steering column, there are going to be trim bezels or covers for the steering column, so a lot of the internal parts of the assembly are concealed for visual aesthetic purposes. These usually mount in different halves and can be latched together with clips to fit around the components and then interlock together. And then with mounting screws, mount to the steering column in various locations. Each vehicle is going to be different, and it's going to allow for things like the tilt steering column adjustment lever, the ignition lock cylinder, and other pieces. This one is missing the upper piece that bridges the top. The steering column tilt assembly may need to be lowered in order to maintain clearance of removing the panels around the dashboard and instrument panel cluster area. So these are plastic, they are breakable. It's best to look up service information. If you can't find all the fasteners or if something's not coming off, it's best not to force it. And they may be interlocked together to help maintain a clean transition or a smooth transition between the components. Coming off the base of the assembly is the intermediate shaft. The intermediate shaft is the linking shaft between the bottom of the steering column and travels and connects the steering column to the steering gear. Depending on the vehicle application will determine what type of steering gear is used on the vehicle. These will likely have a rubber boot that seals against the firewall down at the floorboard of the vehicle to prevent drafting and water and humidity passing through the firewall. It also insulates noise. The intermediate shaft is usually a two-piece shaft with the telescoping feature in it. Some of these can be moved in and out by hand. Others are only designed to collapse in the event of a collision, preventing the energy from the collision from the front transferring through the steering column, through the wheel, and into the driver. This provides almost a crumple zone like you'd find in areas of the body and the chassis to absorb some of that impact and provide some safety for the driver in the event of a collision. Other types of intermediate shafts will be able to be telescoped by hand to connect and disconnect it from the different components. Sometimes the space does not allow for the intermediate shaft to be a rigid component. So telescoping it and reducing the length of it will help in removing it from the splines at the base of the steering column or where the splines engage at the steering gear itself. When servicing these components or disconnecting at the steering column and the intermediate shaft connection, the steering wheel may need to be moved to a better position in order to remove the bolt with proper clearance. So if the steering wheel is rotated to a better position, it may be easier to get a tool onto that component in order to remove that and tighten it. With the bolt loosened on a split collar at the splines of the steering column, the intermediate shaft may not come off. Before disconnecting the intermediate shaft, it's good to lock the steering wheel in place with a tie down or a bungee, usually looped through the steering wheel and down to the seat frame or some rigid component on the inside of the cabin, to prevent the steering wheel from turning to any other position while it's disconnected from the steering linkage. Think about the clock spring. If the steering wheel is allowed to rotate without being connected to the rest of the system, the clock spring may be in the wrong orientation when going back together on reassembly. If this happens, the clock spring may not be able to compensate for the amount of rotation that the steering wheel is off by. And the clock spring may break during normal operation of the vehicle while the driver is driving the vehicle, which would sever the circuits going to the supplemental restraint system, the horn, and any other electric circuits that are mounted to the steering wheel. Steering wheels aren't usually 100% balanced all the way around their assembly. They're usually heavier at one point, and that may be at the top or it may be at the bottom. But before disconnecting any type of steering linkage from the steering wheel to the steering gear, care must be taken to prevent over-rotation of the clock spring in the steering column assembly. Using a tie-down anchored to the seat frame of the front seat and looped back through is a great way of preventing the steering wheel from falling left or right and becoming out 180 degrees out. The problem is, if the steering wheel were to turn one direction once the steering was disconnected, unless you saw it happen, you won't know which direction it went, whether it went to the left or went to the right. So, when you go to realign the steering wheel, you may be over-rotating the clock spring or rotating it back to the orientation it came from. Again, without seeing it happen, you don't know which direction to turn the steering wheel to correct the direction. Using the tie-down strap or a bungee is a good way to anchor the steering in place and not rely on the locking function of the steering wheel lock at the ignition switch. As this bolt is removed, so before disconnecting the steering column from the steering linkage at the intermediate shaft in this case, make sure that the steering wheel is mechanically locked and don't only rely on the lock cylinder to hold the steering wheel in place. In order to reassemble and have everything lined back up and to avoid having a off-center steering wheel, mark the steering column shaft and the coupler. With the bolt removed, this can then slide off. Now you can see the splines inside the intermediate shaft coupler and the splines on the steering column. The intermediate shaft can connect to the steering column in multiple different orientations because there is nothing stopping it from engaging these splines clocked to any other position. Notice how the relief here, which fits the diameter of the bolt, can allow this coupler to mount in any orientation around the base of the steering column. So marking it with paint is very helpful on these in order to reconnect them to the correct orientation. There's our line there and the line that we made there. So when going back together on reassembly, it'll make things go a lot smoother, so you don't have to come back down here and reposition it, especially if removal or dismounting of other components is necessary in order to gain the access and clearance to remove this shaft. The universal joints on each end of the steering intermediate shaft can wear out. As these wear, there will be little amounts of play that will be very subtle. As the driver is driving the vehicle and holding onto the steering wheel, the wheels are in contact with the ground, and any of the bumps and irregularities in the ground is going to feed back into the steering linkage of the vehicle. Any amount of play that can occur in any part of the steering, including on the U-joints of the intermediate shaft, may translate to a rattle concern, or the driver can feel a rattle in the steering wheel during operation of the vehicle. These are common to wear out. They can also develop play in the splines of the telescoping portion of the intermediate shaft assembly. This is one other component that can contribute to play and driver concern as things wear on a vehicle. Not all intermediate shafts will have a splined end or a spline coupler like this one has. On the bottom side of this, we have two flat relief cuts, and it's an oval shape. So this can only fit this way or 180 degrees out this way, where it meets the steering gear. Other steering shafts, like this one out of the 2005 GMC, has the flat edges to where it lines up in only two positions. Depending on the vehicle manufacturer will determine whether or not either coupler end has splines or is more of a flat shaped oval for fitting into or over a certain component when connecting to the base of the steering column and the input to the steering gear. Both ends will not be the same, as we can see in this example here from the Chevy Cobalt. We have splines on one end and the other end is not splined, but the profile is different. The intermediate shaft from the 2005 GMC Sierra easily telescopes. This is for removal and installation purposes, as well as in the event of a collision. This is not going to resist collapse. When replacement or servicing is complete, the intermediate shaft can be realigned in the same orientation that it was removed with the splines using your reference marks that you made. Then reinstall the bolt and tighten in place. Once it is tightened back in place, then the tie-down strap or the bungee holding the steering wheel in position can be removed and the steering can be freed at that point. This steering shaft out of the 2005 GMC was replaced due to a rattling noise in the steering. It's difficult to feel if there's play, whether it's inside the slip yoke or if it's inside the universal joint assembly. But once it was replaced, it resolved the noise. This was based off of a service bulletin. And just as a reminder, when you're troubleshooting a process and researching trouble codes or symptoms, always refer to technical service bulletins. Service bulletins will lead you to areas that are commonly known amongst technicians in the industry and have been officially approved as popular fixes for certain types of issues or for certain types of concerns. In this case, intermediate shafts of this era of GM were notorious for going bad. So many of these have been replaced on many GMs and resolves that steering rattle issue. But like I said, the play in this component is so subtle, you wouldn't normally think with this removed that there's a problem with it. Only once it's installed in the vehicle and driving do you get the rattling concern that you can hear and feel in the steering column. So always refer to technical service bulletins, or TSBs, when doing your research to narrow down on an issue when addressing the 3 C's: concern, cause, and correction. At the base of the steering column, it may connect directly to an intermediate shaft or to the steering gear itself. Depending on the location of the steering gear, it may be closer towards the firewall, or it may be farther towards the front of the vehicle, and may require the use of an intermediate shaft, or may directly mount to the base of the steering column. The first steering gear we're going to cover is the Saginaw or the worm and sector steering gear. The worm and sector steering gear revolves around the principle of a worm drive, which is what this input shaft is. So this input shaft is coming from the steering wheel, and as it rotates, it moves this radius channel through what's called the ball nut. The ball nut is this piece right here, and these little channels have recirculating ball bearings in it. So once the balls get to the end of their travel, they recirculate back up and around, and they run in a continuous loop. So as the input changes direction, it's going to move the ball nut one way and the other. On the other side of the ball nut are a few gear teeth. These gear teeth engage the sector shaft. The sector shaft is what is splined to the pitman arm. So this is the output of the steering gear. And this gear shaft and this sector shaft is going to pivot back and forth, and as it pivots back and forth, that pitman arm is going to swing one way then the other. And this is the movement that is transferred into the steering linkage of the steering system that we covered earlier. A couple things to note about the splines on the pitman arm. The pitman arm has drive splines on it to engage the tapered stud on the end of the sector shaft. These splines may have what's called a dead spline. So right in here, you can see that one spline is fatter, or the space between the splines is wider than the other splines together. Now this happens to have that same profile every 90 degrees. That means for this to spline to the sector shaft, it could be splined on in 4 different positions. Marking your position when you remove this is very helpful for going back together without problem. The orientation of these two components of the worm and sector shaft are 90 degrees from each other. So as our input comes in from the steering column or the intermediate shaft, it translates that rotational movement to a linear movement. And then that linear movement moves across the sector shaft, converts that linear movement back to a rotational movement on the sector shaft, which is 90 degrees in relation to the worm gear. Mounted in the vise is a complete worm and sector drive gear assembly. And on the base portion, this is flipped upside down to allow for better explanation and visual. But the splines coming off of the sector shaft, you can see the dead spline here, or an extra relief cut, and they're at 90-degree intervals apart from each other, is a tapered spline. So as the splines of the pitman arm are lined up, and the locking washer or the split washer is installed and the nut is installed. Once this is tightened together, this tapered spline on the sector shaft engaged with the tapered spline on the inside of the pitman arm are going to be wedged together, much like a tapered ball stud is on a ball joint or on a steering linkage assembly. With the tapered ball stud mounted together, it requires a shock to remove. Well, in addition to that, we've increased the surface area of the taper by adding splines all the way around it. So this has an increased amount of clamping force, plus given the size and strength of this component, a special tool is going to be required to remove that pitman arm once it has been torqued to specification. To remove the pitman arm, there will be a tool that grabs the back side or the top side of the pitman arm and presses on the sector shaft. And as you tighten the tool, it's going to force those parts against each other and then remove the pitman arm. This steering gear is a cutaway model for training purposes, but we can identify some of the same things from the outside, like the sector shaft drive with the dead splines, the input shaft, and the splines for the input on the worm shaft. Looking on the inside, this is our ball nut, and it moves up and down the length of the worm gear. This shows a little bit better how these are configured inside of a vehicle. We can see the teeth here from the ball nut engaging the sector shaft. Sometimes sector shaft to ball nut play can be adjusted for wear. It can only be adjusted to the point where it doesn't bind. If there's wear on the gear teeth in contact with each other here, and that latch or that gap, that play, is adjusted out, it may bind anywhere off of that point. So as long as the steering doesn't bind, you can adjust that play a little bit. This is off of a vehicle that has power steering. The power steering lines connect to a port here and a port here. The power steering lines connect to these two ports, and fluid is then routed into these channels, and as we have the cutaways, you can see the internal components exposed. And when the driver is turning, the valving will direct the fluid in the correct direction to provide assist along the rotational components of the gear itself to help provide assist. This may seem a bit undersized for producing power steering assist, especially on such a heavy-duty component, but remember how much pressure these systems have. Over 1,000 psi, 1,500 to 1,800 usually. So that amount of pressure is being maintained inside this unit when there is steering occurring and when the driver input requires assist from the power steering hydraulic pump assembly. The pump is constantly spinning and providing fluid flow for the system. In doing so, the system has to be able to bypass while there's no actual steering occurring to prevent pressure spiking. On the inside of these pieces is a rotational valve that's going to change direction with driver input, effectively routing pressure to the correct side or the desired side to provide power steering assist in the direction the driver is going to need it. Sometimes debris can be lodged in here, or these pieces can stick or fail, and we may have power steering in one direction and not the other. We may not have power steering in either direction, or the steering may try to steer itself. Remember that rotational valve assembly is sensing which direction the driver is inputting steering pressure. If that valve sticks, it may continue to provide steering assist when the driver is not inputting any force to the steering wheel, resulting in the vehicle steering itself, and the driver will likely be fighting that steering pressure when trying to turn the opposite direction if the valve stays in the same position. Steering gear assemblies are typically not serviced or repaired in a normal shop setting. A dealer shop, an independent shop, or a chain shop is usually going to remove the component and replace it with a new or a remanufactured or rebuilt component. Because of this, it's unknown what orientation the steering gear is in before it gets shipped out from the rebuilder or from the manufacturer. Because of this is why it's important to center the gear mechanically first before attaching it to any components in the steering system. Some vehicles require removal and installation of the gear itself in order to connect it to the steering at the input. If that's the case, and something was done incorrectly with the orientation of the steering gear may have to be removed after installation in order to correct the position of it. So as standard practice, always double check and make sure that the steering gear is mechanically centered before installation into the vehicle. It's also important to make sure that the steering gear matches the one that was removed from it. Since it's a different part, there's possible differences that can occur if the incorrect part was shipped or ordered. Always double check the identifying characteristics of the gear that you're replacing to make sure everything matches and that everything going in on reassembly is going to match up. It's not uncommon for there to be differences and to not find those differences until it's been installed in the vehicle, and by that point much time has been taken to get to that point, and the technician would then have to remove the component from the vehicle and then ship it back to get the correct one. The rack and pinion steering gear is made of two basic components, the rack and the pinion. The pinion is splined to the input shaft, where it attaches to the intermediate shaft up to the steering column or directly to the steering column itself. This one is shaped with a relief here for the pinch bolt and has two flat sides on it. So the coupler would fit over and the bolt would pass through, pinching both halves together and cinching it to the input shaft of the pinion gear. Then at the helical cut gear profile, it will engage the rack and convert that rotational movement to linear movement. The rack component of a rack and pinion steering system is what takes up the job of the center link in a parallelogram steering system. This is all housed within the assembly, and the housing will have mounting locations. They could be mounted in this style, or they may have bushings that mount them to the frame. The housing will also, if it's equipped with hydraulic power steering, may have ports for the steering lines to connect to, and also ports for that power steering fluid pressure to be routed to either end of the rack on these different ports along the housing. For hydraulic power steering on a rack and pinion assembly, the rack in its centered neutral position will place the hydraulic seal in the middle of these two ports. Depending on the direction of steering input from the driver into the pinion gear, we'll route the fluid pressure from the inlet and outlet and route it out of the corresponding port to provide pressure in the direction of steering from the driver. So with this seal here and pressure provided to this side, it is going to provide assist this direction. That when the driver changes direction on the steering wheel, pressure coming out of the housing, pressure coming out of the rotary valve is going to be routed to the opposite side to provide fluid pressure in the opposite direction and assist the driver steering back the other way. Depending on the driver's input is going to depend on which way fluid pressure is going to be coming in, and then the displaced fluid would be going back out to the valve assembly and recirculated back into the hydraulic system. Taking a closer look at the pinion gear, our rotary valve can change direction without influencing the direction of power steering on the pinion. This pinion gear and valve assembly are off a different type of steering rack where the power steering pressure is applied to the pinion shaft itself. That allows this to spin independently of the pinion gear and for fluid to be fed through these different channels and ports to provide steering assist directly on the inside portion of this, which has pressure and relief channels machined into the pinion gear itself. With the retainer ring removed, you can see where the fluid would be forced into these spaces here and would either push this direction or would be pushing in this direction. Similar opposing reliefs are cut on the inside of the rotary valve assembly itself. So this rotary valve and this pinion gear are actually what's receiving and distributing the power steering one direction versus the other. This design would not include the steering assist providing ram assist from either side of the rack assembly itself. So two ways of accomplishing the same goal: either provide pressure to the input on the steering gear itself at the pinion, or provide hydraulic force to the rack itself and help push the rack left or right. Depending on the manufacturer and the vehicle, will depend on how the system is configured for hydraulic steering assist with a rack and pinion steering assembly. Here's an example of the assembled unit. And again, rack and pinion steering gear assemblies are also not serviced in-house. They will be shipped out as a core to be rebuilt or replaced with a new unit. The same rule applies. Before installation, make sure the rack is centered. And if your steering was not centered on the vehicle prior to removal, it may need to be centered before installing the new gear at the centered position, or calculate the amount of turning that the steering system is already at and adapt the new gear to that orientation. So our hydraulic power steering lines will come into these ports. The rotary valve assembly will route the fluid pressure into the corresponding lines that follow down the rack body and will provide pressure to this side and return on this side during this direction, and pressure to this side and return on this side during turning in this direction. Unlike the Saginaw or worm and sector drive gear, adjustments are not made on this assembly at any time. Any adjustments are made during the manufacturing or the rebuild process, and the preload is established through this base plate here. These should never be removed or adjusted for any type of rack and pinion steering gear in the field. If the system is worn out and the rack and pinion is determined to be faulty, it needs to be replaced. When we were discussing these assemblies previously and servicing of the inner tie rod ends, you might remember or recall these bellows boots. There is no fluid inside of the bellows boots. It is there to protect the end of the rack and to protect the inner tie rod end from dust, debris, and other contaminants. As the steering moves one way versus the other, as this bellows boot is compressed, that air is transferred through a tube that connects to this port right here to a similar port on the other boot, and the air is displaced into the expanding bellows boot on the opposite side. This prevents pressure from building up inside during turning and allows that air somewhere to go, and directly into the opposite side is the most feasible place to put that air. So these systems remain sealed to external contaminants. When performing an alignment, it may be necessary to remove the bellows boot clamp to allow for the rotation of the inner tie rod end during the adjustment. If this is not done, the boot can become twisted if it wasn't released during the adjustment to allow the rotation of the inner tie rod end. This will ruin the boot. The bellows boot should not be tight against the inner tie rod end during the adjustment. And then once the adjustment is made, put the clamp back over the boot so it stays in place. From the steering column example from earlier and the power steering electric motor attached directly to the steering column, this is another way electronic power steering can be configured. This mounts the electric motor directly to the power steering rack itself, and it drives on part of the steering rack that is at a different location than the input coming in through the pinion gear. Notice the sensor here on the pinion gear assembly and the wires going to the electronic power steering module. This sensor is going to determine how much force is being applied to the steering wheel in the direction of steering, and the module is going to receive that as an input, determine what needs to be done, and output a command to the electric power steering motor for what's needed at the power assist in the steering rack assembly. This doesn't have any fluid. It operates off of electricity, again using inputs and outputs with the module. One other thing I want to point out on this. Notice this inner tie rod end, nice and straight. Now look at this inner tie rod end, nice and bent. This likely happened due to an impact at the wheel on this side. With the R, this would be the right side of the vehicle. So if there was an impact on this that caused damage to the inner tie rod end, the question is, would the correct repair be replacing the bent component? Or should we ask a deeper question and wonder if that shock translated into this component and into this electronic motor assembly, did that cause damage to the motor? Well, what I can say, since I don't know the vehicle that this came off of or what happened to it, but what I can say is that this rack was removed with the bent tie rod end. So that leads me to guess that the technician recommended replacement of the entire rack assembly due to the damage and the impact that occurred on this side, potentially causing damage to this component and somewhere else in the steering rack assembly. These are things to think about when we're recommending repairs and finding faults in the system. Depending on the application, the year, the make, and the purpose of the vehicle will likely determine what type of steering gear is used in it, along with whether or not it has electronic power steering or hydraulic power steering or any power steering. The steering gear's job is to take the driver input from the steering wheel through the steering column and possibly the intermediate shaft and provide a gear reduction and move the steering linkage with the gear reduction so the driver's force is magnified or amplified into the steering linkage in order to steer the vehicle. Chassis weight or the vehicle weight will have an effect over what design is used. More vehicles are going to be rack and pinion style steering. And even on truck models, like the 2005 GMC, somewhere around the 2011-2013 mark is when they converted those steering linkages from parallelogram or conventional steering linkage to a rack and pinion steering system. The rack and pinion steering system has fewer moving parts and will develop less play over time, resulting in safer handling of the vehicle and less maintenance on the system. It also provides less space that the steering linkage takes up by having a rack and pinion assembly. So always consult with manufacturer recommended procedures and service information when servicing these systems. And always remember, airbag systems, SRS systems need to be deactivated in order to be safe to work on. There's always going to be a safety procedure in how to do that on each vehicle. Simply disconnecting the battery or removing the fuse is not enough to disable the system in all cases. Also, before disconnecting anything connecting the steering wheel to the steering gear, the steering wheel should be mechanically locked, and not just with the ignition lock cylinder locking feature, but by tying the steering wheel to something rigid in the cabin space to prevent it from turning one way or the other so it doesn't over-rotate the clock spring and damage the clock spring. I hope this has been informative, and I hope that we can get into more of these in lab. And until then, I'll see you on the next one. Thank you.